Hi, my name is Giancarlo Espina, and this is a presentation video of the synthesis of aspirin experiment that I conducted with my partner Chase Ruff for period 6 of AP Chemistry. To begin with, our intention was to compare the amount of ASA, or acetylsalicylic acid, which is the main component of aspirin, in pharmaceutical aspirin that is sold in drugstores and pharmacies, to lab-synthesized acetylsalicylic acid. We were going to compare this to pH with a pH sensor. Our hypothesis was that if we synthesized a purified acetylsalicylic aspirin product, the pH would be lower than that of pharmaceutical aspirin. This is because pharmaceutical aspirin contains things other than ASA, such as cornstarch and binders, to keep the pill together, rather than pure ASA, so that means there's a lower concentration of ASA, which would result in a higher pH. Here's a reaction. It's known as an esterification reaction. So here a phenyl group of salicylic acid reacts with a carboxyl group of acetic anhydride to form an ester, and then the resulting products are acetylsalicylic acid and acetic acid. This is all done in a 1-to-1 stoichiometric ratio, and as such, salicylic acid is the limiting reagent in our experiment because we use 2 grams of salicylic acid to 5 milliliters of acetic anhydride, meaning acetic anhydride is in excess. When salicylic acid and acetic anhydride are mixed together in the flask, there is excess acetic anhydride. However, this acetic anhydride is converted to the acetic acid you see on the product side when you add water. Here are the materials we used. Here is salicylic acid, a main reactant, acetic anhydride, the other main reactant, 18 molar sulfuric acid, which was a catalyst for the reaction, distilled water, a 125 milliliter Erlenmeyer flask, a 600 milliliter beaker, which was used for ice and hot water baths, a 10 milliliter and 25 milliliter graduated cylinder, which were used to measure out the ethanol in the water, and then the vacuum filtration apparatus and other substances over here. And then here's the procedure. The procedure basically entails adding 2 grams of salicylic acid to 5 milliliters of acetic anhydride, all under a fume hood, in a 125 milliliter Erlenmeyer flask. Then 4 to 6 drops of the 18 molar sulfuric catalyst is added to the mixture, and then it is placed in a hot water bath for 10 minutes and allowed to boil there. And then it is taken out and placed in an ice water bath where it begins to crystallize. We then decided to purify it using an ethanol to water ratio, and then we would run this through a vacuum filter to take off any excess water. However, we did have problems with the ethanol to water ratio, as originally we were using a 1-to-2 ethanol to water ratio, and we found that this produced watery, slushy mixtures in which the ASA crystals were suspended in solution, and it would not crystallize completely unless you significantly lowered the temperature, such as by placing it in a refrigerator, which we did. We also had problems with the vacuum filtration, as seen over here. The vacuum filtration was used to filter out the water that the ASA crystals were in, and it was connected to the sink over here, not pictured. And as you ran the water through the sink, it would create a vacuum in the vacuum tract, and it would essentially take out the water that the ASA crystals were suspended in over here in the funnel, just leaving the ASA crystals here. However, we found that sometimes the ASA crystals are very small, and a lot of them would be filtered out with the water into the flask, and we'd lose a significant portion of the actual ASA crystals, which would contribute to a low yield in the end. And then we actually achieved a 30.45% yield, which is not ideal. Here's the purification of the crude product, in which we used ethanol, as I stated before. Here is weighing it and calculating the percent yield. And because everything is in a 1-to-1 stoichiometric ratio, the moles of salicylic acid should be equal to the moles of acetylsalicylic acid. So, in the end, 2 grams of salicylic acid should produce about 2.66 grams of acetylsalicylic acid to get 100% theoretical yield. Here is part 4, in which we actually compared the lab synthesized acetylsalicylic acid to some pharmaceutical aspirins. We used Bayer aspirin, which is a common brand of aspirin, and then some generic drugstore aspirin. And we measured all this with a pH probe connected to a Spark device. Here is a video reference of the actual experiment done at a North Carolina School of Chemistry. We found this video very helpful, and her procedure and steps that she did were helpful as well, but we did use different ratios and amounts than what she did, and we ended up with a different result. However, we still found it to be quite helpful and appreciated the making of this video. This is the video of us personally preparing it in lab. Over here, as you can see, is the sulfuric acid and the acetic anhydride. This is all done under a fume hood because acetic anhydride is volatile and it could burn your eyes as well as sulfuric acid. And here is the salicylic acid in the Erlenmeyer flask. We took great precaution not to burn ourselves with the sulfuric acid using rubber gloves and pipettes. Here I am taking the acetic anhydride out. We use 5 milliliters of it and pouring it into the flask. This is mixing it all together after the sulfuric acid catalyst has been added. We swirled it around and then placed it in the hot water bath. Notice the color of it now. As it continued to boil, it would get darker in shades, and by the end of the heating, it got significantly darker than it was to begin with. And then we placed it in a hot water bath. Here are some photos of the lab we conducted. Here is trial 3 in an ice water bath. Here is a discarded trial that we actually believe boiled too long, and one of the side reactions, a polymer is formed, and that could be burned. In this trial, we had a sort of sludge, thick viscous mixture in which it was very viscous, and it was not easy to filter out. We decided to discard this trial as it was only one of the first trials, but we did learn from our mistakes from this and decided not to repeat the same mistakes by allowing it to boil over. Here is the pH probe that we use to measure the pH of the pharmaceutical aspirin to this lab synthesized acetylsalicylic acid. It's connected to a Spark device here, and what we did was, because acetylsalicylic acid is a weak acid and as such only dissociates to a small extent, it had a very small Ka. So 0.3 grams of acetylsalicylic acid is soluble in 100 milliliters of water. So we placed around 0.3 grams of the lab synthesized acetylsalicylic acid and 0.3 grams of the Bayer aspirin and the generic drugstore aspirin, respectively, in 100 milliliters of water, and then we use the pH meter to calculate the pH once it was all dissolved. However, there was still some portions of it that weren't dissolved, which is understandable, considering it's a weak acid with a small Ka. Here's our data. For the first trial, we did not purify it in 2 steps as we did for the other 2 trials. We just wanted to see what would be produced, and here's the mass of salicylic acid we started with, and then the mass of the acetylsalicylic acid that we ended with. And according to theoretical yield, the most acetylsalicylic acid you should get is about 2.66 grams of ASA. So because we got 3.1763 grams, we actually ended up with over 100%, being 157% yield. This is because of the impurities in it that were not filtered out, and it's understandable. For the second trial, we did purify the product, and we used 2.0140 grams of salicylic acid, which resulted in 0.1667 grams of salicylic acid, producing a 6.35% yield. Nowhere near ideal. As I stated before, we had problems with the ethanol to water ratio, and which produced small crystals, which a lot of them filtered out with in the vacuum filter. And then in trial 3, we had a better yield. However, it was also not ideal, as it was a 30.46% yield. In the pH comparison, we found that the drugstore aspirin and the Bayer aspirin actually had a lower pH than the lab synthesized ASA, which is not what we expected and went against our hypothesis. The lower pH indicates a higher concentration of acid, and we believe that we had other impurities in our products that may have contributed to its higher pH. And upon experimentation, we would take great care to improve the purification procedure, to take out impurities and retest the pH. Here are some photos of the crude product, and then as you can see here, we ended up with significantly less amount of purified product, because after the purification process of the ethanol and water, small crystals were produced instead of the large crystals we were expecting, and a significant portion of these were filtered out through the vacuum filter. And that concludes this video. Thank you for watching.